Welcome to Concertal Systems Design Portal, where users gain access to valuable system design automation capabilities that allow them to move quickly from concept to full chip simulation. Together, players orchestrate, audition, and rehearse provide a powerful new approach to chip design. In this video, I'll be introducing Rehearse, Concertal's server-side tickle-based simulation engine. We'll be using our previous example design from the Introduction to Orchestrate Rapid SDA Design video. Once again, the previous example was a simple design that could take input digital signals from a variety of sources, such as an on-chip signal generator, 1 to 4 channels of PWM inputs, 1 or 2 channels of PDM sensor inputs like from a digital microphone, and 1 to 4 channels of SPI digital signal data inputs. And it could translate those signals to 1 to 4 channels of PWM outputs or 1 to 7 channels of SPI outputs. We start by logging into the Concertal SDA portal, which brings us right to our dashboard. As you can see, one of my recent designs that I've been working on is my example design. That is the example design that we built in the last video. There's 2 buttons here. The green edit button allows me to change the definition of that design, either add or take away IPs or customize the relationships between the IPs if I want to further optimize the design. The blue button allows me to go right into Rehearse, which we'll do at this time. You may notice that the previous builds location of the window shows no previous compilations of the design. Since we just specified this design and haven't gone into Rehearse yet, there will be none shown. The first thing we need to do is actually compile the design. We do that by specifying some notes to remind us of the configuration of this particular compilation, and select the Build New button. It's at this point when System Design Automation is working its magic. It's taking the IPs that are defined in the design, pulling them from Configuration Management, searching through the design database, which indicates how the IPs are to relate together as a system, and building wrappers around all the IPs based upon the way the IPs are intended to be used. Once again, we didn't specify a lot of relationships in this particular design, so it's building a highly configurable design where the user at runtime will be able to actually configure how the IPs are going to be talking with each other at runtime. It's also building the interconnect fabric to tie all the IPs together. It's building another design which acts as a test bench to the main design, allowing us to apply stimulus to all the input pins, as well as to monitor what's going on with the output pins. It's building the debug ports to the simulation environment and compiling all this together as a simulation with a tickle-based user interface. As you can see, the build is now complete, and we'll refresh the screen. And as you can see, we now have a compiled design ready for simulation and Rehearse. Rehearse allows multiple builds for different versions of a design to be readily available. Compiled simulation builds with any embedded simulation scripts are kept on the server, and they can be picked up by others, providing a collaborative simulation environment for access by any stakeholders in a design. For now, we'll select the green button to load the compilation into the simulation engine, select simulation, and we're now actively simulating this design. The tickle-based console runs with any standard web browser without installing any software. And it allows us to manually interact with the simulation engine or run simulation scripts. At this point, since this is a new design, we have no system scripts to run on this design. So I've taken the liberty ahead of time to create a script which I'll simply paste into the script editor and will run the simulation. To do that, we begin by entering the script editor and we select a name for the script. I'll call this run.do, and we'll simply paste the contents in here that I've already prepared. Now, before saving and running the script, let me talk you through it and explain what it's going to be doing. The first part of the script simply selects signals from the simulation engine and specifies that we want to display these signals in the waveform viewer. And that's followed by an open VCD command, which opens a stream between the simulation engine and the client-side waveform viewer. Players-based IP, including the system handler, which represents the fabric within the design that's generated, has the ability to inherit procedures and scripts that can be reused in the system simulation environment. Line 31 initializes some procedures that we want to use for reading and writing internal registers to make it easy for us to control the simulator engine. And the defaults are things such as the power on reset settings and default clock frequencies, which we override with the set statements. There's also a script called initSim, which actually applies the power on reset circuitry, and we run for 5,000 ticks, and now the simulation is ready to accept application-based commands to operate the part. The remainder of this script is simply setting configuration registers in the design and the test bench to specify stimulus, internal clocks and internal data routing, IP mode controls, and runtime controls. Once again, this particular compilation of the design was generated as a highly configurable design, so there's lots of control registers to set the chip up to operate as a system as we want to. All of these registers can be optimized in Orchestrate, and the design regenerated to only include the amount of flexibility that you want to extend to an end user that you really need to for your system. So now that we have our script ready, we'll save the script. And we'll go back to the Rehearse simulation. And as you can see, under the available category items, the script now shows. We can simply run the script by selecting it. The script is now being executed with the simulation engine. As you can see, the waveform generator is showing the signals we selected. The first set of signals is the on-chip signal generator, which is generating a digital sine wave with a DC offset at a specified sample rate. That output is being routed to the GPIO pin 0, which is operating as a PWM output, taking the sine wave data and creating pulse durations of the specified width. The SPI is also outputting the data, which is going over to the test bench and being received, and the test bench is routing that data to the sigma delta modulator that's providing the PDM output as a stimulus into the PDM input IP, or the digital microphone IP. Thank you for watching this introduction to Rehearse. Be sure to look for our other introductions to optimizing designs with Orchestrate and using Audition to specify and import players' IP.